Indices. Indices simply means index numbers. But what do we mean by index numbers? If we have a variable a multiplying itself twice, and then a third one, and then a fourth one. This one, the best way to present this is to say a is multiplying itself 4 times. And so if I have b to the power 6, what this means is that I have b multiplying b, multiplying another b, multiplying another b up to 6 times of b multiplying itself. So when we have a number like 1000, and then we say that, well, if you see 1000, it means 10 is multiplying itself 3 times. And so 1000 can be written as 10 to the power 3. That is what we mean when we talk about index numbers. So how do we explain it? Now, as we just saw the superscript that we see, we call it exponent. The exponent tells us the number of times the number in question that we are dealing with, or we are talking about, is multiplying itself. And that number in question, we call it base. So in indices, we should know what we call base, and then we should know what we call index or exponent. So if I have a term or an expression a to the power m, then a is the base. That is the actual number or the number we are talking about. And then m shows us the number of times a is multiplying itself, and m is the exponent. So this is what we should know when it comes to indices. So when we talk about an index number, we are saying a number raised to the power something. And that power, or which we call superscript, tells us how many times the base is multiplying itself. And so I will give you a question: 2 to the power 8. What does this mean to you? This means that 2 multiplies itself 8 times. I hope you got that right. Good. Now we look at some laws and properties of indices. Now let's do this illustration. If I have a to the power 2, and then I want to multiply this by a to the power 3. First of all, let us decompose them, or we should write it in its multiplication form. So we will have a multiplying a, that is 4, a to the power 2, multiplied by a multiplying itself 3 times. Okay, so this one is also 4, a to the power 3. So now we are doing multiplication. We are multiplying what's in this first bracket by what is in the second bracket. So that gives us a times a times a times a times a. And if you are to rewrite this in index form, we're going to have a to the power 5. Let's take another one. If I have m to the power 5 and then I multiply by m to the power 6, what that means is that I'm going to multiply m by m by m by m by another m, and then all this multiplying m by m by m by m by m by another m. So when I expand, when I open the bracket, what I'm going to get is going to be m multiplying itself the number of times in the first set together with the number of times in the second set. So m multiplying itself. So this is 5 making up for the first set, and then the second set continues. So this is also 6 making up for the second set. So all together, if you are to convert or write it in index form, we are going to obtain m to the power 11. So looking at the illustration here, you can see that for a to the power 2 and then a to the power 3, when we did the multiplication, we had the result to be a to the power 5. So let's try to connect the exponents. So this one is 2, this one is 3, and this one has become 5. What do you think is the connection? Have we added 2 to 3 to give us 5? Okay, I can't say yes. Maybe we will all conclude after the second example. So for the second example, we also have m to the power 5, m to the power 6 multiplying. And the result we had is m to the power 11. So connecting the two, what's our conclusion? 11, 5, 6. When you add 5 to 6, does it give 11? So is it an addition? Okay, so that is if you have two numbers that are of the same base, numbers, exponential numbers of the same base, and we multiply them, the exponent will add up. So if I have 2 to the power 2, and then I multiply that by 2 to the power 6, from the examples we have looked at, this will give us 2 to the power 8. Now let's look at this one. Assuming the two numbers are 3 and 2, so 3 to the power 2 multiplying 2 to the power, let's say 4. When I do this multiplication, what will happen is I'll get 3 times 3 multiplying 2 times 2 times 2 times another 2. So here I get 9, here I get 2, 4, 8, 16. So I get 16. You see that these are not two same numbers. So I can't put them together to become 6, the exponent to become 6. Now if the exponent becomes 6, then it goes with which of the bases? Is it going to go with base 6 as multiplying 3 and 2? No, we don't do it like that. And then we cannot also say it's going with base 3 nor base 2. So when the bases are not the same, the law does not apply. So let's take note. So if I have a to the power 2 and I multiply by b to the power 2, the result is going to be a to the power 2, b to the power 2. So we can't put them together. They don't have the same base. Okay. And so let's note that in our first law, which I have tagged as the first nugget, when the bases of two numbers are the same and we multiply them, we take one base and then add the exponent of the two bases, as you see here. Okay. The second law, before we look at the law, let's take some illustrative examples. If I have a to the power 5 and I am dividing by a to the power 3, because it is division, I can rewrite it as a to the power 5 over a to the power 3. So I'm going to decompose a to the power 5 as a times a times a times a times a, and then divided by a to the power 3, which is a times a times a. Okay, now in fractions, when we have common factors in the numerator and the denominator, we cancel them out. Okay, so in this, we can see that a can cancel a. So a goes here, one goes here, another one. Another a goes here, one goes here, one. Another a goes here, one goes here, one. Okay, now let's multiply the remaining values. So a to the power 5 divided by a to the power 3 gives us 1 times 1 times 1 times a divided by 1 times 1 times 1. And this gives us 1 by 1 by 1, which is 1 times a times a to the power 2 divided by 1. And that remains as a to the power 2. Okay, so now we see that we go back to the question given, or the given expression, and the result we had is a to the power 2. Now let's take another example. If I divide m to the power 10 divided by m to the power use 5. So this one, I will rewrite this as m to the power 10 divided by m to the power 5. So m multiplying itself 10 times. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So m multiplies itself 10 times divided by m multiplying itself 5 times. So m, okay. So now I have them like this. Let's cancel out the common factors or the common multiples. So m goes here 1, goes here 1. M goes here 1, goes here 1. M goes here 1, goes here 1. M goes here 1, goes here 1, and then here 1. This gives me m times m times m times, so I have 1, 2, 3, 4, 5 left. M times m divided by 1. which gives me m to the power 5 over 1, which is so equal to m to the power 5. Okay, so this second example also gives us the result m to the power 5. So what is happening here? Give me your observation. It's just unfortunate that I can't hear you, but I believe you observed that the exponent of the divisor subtracts the exponent of the dividend. So I have this being divided by this. So this becomes the dividend, the number being divided, dividend. And then this is the divisor, is the number that is dividing the other. So what happens is that we take the base and then we subtract the exponent of the divisor from the exponent of the dividend, like this. And that is our second nugget, or our second law of logarithm. Once again, this one is indices, our second law of indices. Once again, let's remember that the law applies to numbers of the same base only. Okay, so if I give you 2 to the power 20, and this is divided by 2 to the power 19, don't even trouble yourself using calculator to find the exponent of 20, 2 to the power 20, then afterwards you divide by the exponent. No, 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 that would be too much. By indices, you simply get to know that we have 2 to the power 20 minus 19. It's as simple as that, and that result is 2. I hope this is understandable. Okay, so now I'm still looking at the same law. It looks like in all the examples that I gave, the exponent of the dividend is greater than the exponent of the divisor. And so I always get a positive number, or let's say a number as being the resulting value. So when I give something like 8 to the power 5 divided by 8 to the power 3, the result was 8 to the power 2. When I give m to the power 10 divided by m to the power 5, the result was m to the power 5. So interesting and simple. Now let's look at a situation where the exponent of the divisor and the exponent of the dividend are the same. So assuming I have a to the power 2 divided by a to the power 2. Now from what we have seen, this one gives us a to the power 0. Is that not so? Okay, let me go slow. So a to the power 2 minus 2, which gives us a to the power 0. Okay, now a to the power 0, we will let it be as it is. Then we now convert it to normal fraction or common fraction, a to the power 2 divided by a to the power 2. This one can be written as a times a divided by a times a. So let's cancel out the common ones. A goes here 1, goes here 1. A goes here 1, goes here 1. And this gives us 1 over 1, which is 1. Okay, so what that means is that if I have a to the power 0, it is the same as 1, because a minus a to the power 2 minus 2 gives us a to the power 0. The same expression gives us 1. So then we can conclude that a to the power 0 is equal to 1. Okay, so any number to the power 0 is equal to 1. It's not equal to 0. So if I have 10 to the power 0, the result is 1. If I have 100 to the power 0, it is equal to 1. If I have 20,000 to the power 0, it is equal to 1. So let's take note of this. Now let's also look at a situation where the exponent of the dividend is lesser than the exponent of the divisor. What will happen? So if we have a to the power 2 divided by a to the power 3, so here the dividend is greater, the exponent of the divisor is greater than the exponent of the dividend. This gives us a to the power 2 minus 3, which is a to the power negative 1. Okay, so now let's also rewrite it as in the fraction form. So we have a to the power 2 divided by a to the power 3. So a by a divided by a by a by a. This, when we do the cancellation, we are going to have this one, and then this one. So the numerator will be 1 and the denominator will be a. What it means is that a to the power negative 1 is the same as 1 over a. So that is something we should take note of. Are we good? Okay, so this is to the power 1. What of if it is to the power more than 1? How do we write it? So what that means is that if a is to the power, let's say negative 2, does it mean it is negative, it is 2 over a, or does it mean it is 1 over 2 to the power 1 over a to the power 2? So let's also try and then see what it means. Okay, so let's use the example m to the power 5 divided by m to the power, let's say 8. So this one will give us m to the power negative 3, right? By our law, and then the calculations that we can do. If we are to do the cancellation, we will have m to the power 5 divided by m to the power 8. So m by m by m by m by m, and I'm dividing by m by m by m by m by m. Okay, so now let's do the cancellation. This one here, one here, one there, one here, 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 one here. Okay, so this gives us 1 over m to the power 3. So what conclusion do you draw? If I clean this one and then write it here. So we have m to the power negative 3, and this is the same as 1 over m to the power 3. So this is how it should be. This is how we present it. Okay, so I hope this one is understandable. We have established that a to the power negative 1 is the same as 1 over a. And then we have also seen that a to the power negative n is equal to 1 over a to the power n, right? Good. Now, if I have my base to be a fraction, a over b, and then to the power negative 1, what will the result be? So it is going to be 1 divided by a over b. I hope you agree. So let me put it in brackets like this. But I want to rewrite this as 1 divided by a over b. I hope this is allowed. And then since it's division, I can multiply and reciprocate the dividend to be b over a, right? That gives me b over a as a result. So I can conclude that a over b to the power negative 1 is the same as b over a, right? The third law, if I have two numbers multiplying, so a, b to the power 3, then I can rewrite it as ab times another ab times another ab. That's what it means. The base is a pair of numbers. So when I'm multiplying, I take the base to multiply itself 3 times, and the base is AB. So this is how it becomes. Now when I do this multiplication, A will multiply itself 3 times, giving me A to the power 3, and B will also multiply itself 3 times, giving me B to the power 3. I hope you agree. Good. So if I have 2 times 3, and then they have exponent 2. What it means is 2 to the power 2 multiplying 3 to the power 2. That's what it means. Let's see if it is true. So here, let's multiply what's in the brackets first. That will give us 6 to the power 2. And then here, let's do the expansions first. So 2 to the power 2 will give us 4, multiplying 3 to the power 2 will give us 9. So 6 is 36. And then 4 times 9 is also 36. So you see that they are equal. Good. So the third law says that if you have two numbers as the base numbers to a power, the exponents affect both of them, both of the multiplying numbers. Please note that the numbers are multiplying. Note, so AB means A multiplying B. There is no plus or minus in between them. They are multiplying. So look at the situation here. The one I've put notes there. This one is A plus B all to the power n. This is not equal to A to the power n plus B to the power n. Take note of that. This one, A, B, they are not multiplying. Even though they become our base, but they are not going to give us this exponent. I will illustrate for you to understand better. Okay, so let's say we have a plus b to the power 2. What this means is that a plus b multiplying a plus b, right? This one is correct. Good. So I want to open the bracket. So I have a multiplying a plus b, and then plus b also multiplying a plus b. I hope you remember this. Okay, so now let's expand each bracket. So I have a squared here plus ab plus another ab plus b squared. This will give us a squared plus 2ab plus b squared. So look at this result. Is it the same as a to the power 2 plus b to the power 2? No. So a plus b all to the power 2 is equal to this. It is not equal to this. It is not equal to a to the power 2 plus b to the power 2. They are not the same. So take note. So this law applies to two numbers, base numbers that are multiplying. So we need to take note of that. So this is what we have. Okay. So this is the law that we have. Okay. Now let's also look at a situation where the base is a dividing number. What will happen? So let's take an example. If I have a dividing b and all are to the power 4, what I will get is a over b multiplying a over b multiplying a over b multiplying another a over b. So multiplying 4 times. Now this is multiplication, so the numerators will multiply and the denominators will also multiply. So we have a times a times a times a, which gives us a to the power 4. And then b times b times b, which also gives us b to the power 4. Yes, so this is what the law says, that if there is a fraction 7 as a base with an exponent, there is a fraction 7 as a base with an exponent, the exponents affect both the numerator and the denominator individually. So that's the law we have. So another aspect of the second and the third law, if we take the fraction side, is the same thing. Are we good? All right. Now let's look at this equation here, what it also means. So if you have a to the power 2 and then everything is to the power 3, what happens is we will have a to the power 2 multiplying itself 3 times. I hope you agree. Good. Now for each one we open, or if we are to even apply the multiplication law, the first law that we looked at, then the same base multiplying, we add the exponent. That gives us a to the power 2 plus 2 plus 2, which is a to the power 6. Now when you look at the 6, and then the 2 and 3. So we are relating the 6 to this 2 and 3. So the connection is that the 2 multiply the 3. That's what it means.